Hello students, I hope you are all doing well. So in class 9th, the first chapter that we are going to cover in physics is motion, and this motion is very interesting chapter. Before proceeding the chapter, let us see what all topics are there in this chapter. So we'll understand the concept of rest, motion, distance, displacement, speed, velocity, acceleration, uniform and non-uniform motion, graphical representation of motion, and equation of motion with its derivation and numericals. Numericals is going to be the fun part. And the last topic is uniform circular motion. So what do we understand with the term rest? Rest means if some body is not changing its position. So we can define that a body is said to be at rest if it is not changing its position with respect to a fixed point of its surrounding. And if the body is changing its position continuously with respect to a fixed point, it is said to be in motion. So this concept of rest and motion both are relative. Why? Because this rest and this motion can be different for different frames. If we take example of a train, suppose you are traveling and there are two friends. One is traveling with you and one is standing outside the train compartment. So if the train starts moving for you, your friend who is sitting along with you is at rest. But if someone asks your other friend whether you are moving or not, he will say that no, he is moving. Why? Because for him the train is moving and along with train you are moving. So if we talk about this earth, if on earth we know that earth is rotating, but for us we are at earth and we cannot observe the rotation of earth. But if someone sees from outside of the earth's atmosphere, he can say that yes, the earth is moving. So it is actually all the frame of reference. If we take other example, let us suppose sun. We know, we studied that sun is at rest, but we can say that no, sun is in motion. Why? Because we see that sun rises in east and sets in west. So for us, sun is in motion. Why? Because earth is rotating at its axis and along with earth we are also rotating. But sun being at rest, it comes to be in motion for us because we are moving and it becomes relative. We are in relative motion with that of sun. To understand the concept of reference point, it is very easy. If someone is at origin and Cartesian system, that is xy axis, and some object is changing its position on x or y axis, then one can say yes, the body is changing its position. But suppose if you are moving with same speed, or you can say that you are also moving and the object is also moving in the same system. So suppose towards x axis, and what will happen? You will not be able to see the actual movement of that particular object. As we proceed in the chapter, you will be able to understand this concept in a better way. So in physics, we study two types of physical quantities. One is scalar quantity and the other is vector quantity. This vector concept is something new for you and it is in detail in class 11th, but you will understand few basics of vector in class 9th as well. So if we have to define what is scalar quantity, you can say that a physical quantity is scalar if it has only magnitude, or you can say its size. Suppose we talk about length, then length is in meter, then that meter, suppose 2 meter, so 2 meter is a scalar quantity. But if a physical quantity is described by its magnitude as well as in direction, suppose I say 2 kilometer in north direction. Now this north direction gives us the idea about the position of the object in some coordinate or in some direction. Then this becomes vector quantity. So there are few examples of a scalar and vector quantity. We'll see that. So in scalar quantity, we can say distance, area, volume, mass, speed. Whereas in this vector quantity, we can say displacement, velocity, acceleration, and momentum. So what is difference between distance, displacement, speed, velocity? Once we'll proceed in the chapter, we'll be able to understand. Now, just for your extra knowledge, that this vector quantities follow different rule as that compared of that of scalar. Like a vector has vector sum, vector has vector products, and there is no thing called as division in vector. Alright, so let us see what is distance. We have seen that Lucknow is 265 km from Gorakhpur or etc etc. So what is actually distance? So distance is the actual length of the path covered by a moving body irrespective of the direction. See, we are saying irrespective of the direction means if we are going from any point to other point, or we can say that I am going from my home to surmount the school, so the path that I am covering is the actual distance. So this distance SI unit is meter. If we take the example if we here, so a body is moving from point A to point D, but going from point A to D, it went from point A to B, then from point B to C, and then from C to D. Then the actual distance that it covered was the sum of distance. If we take other example, suppose I have to go to surmount the school. I can take any path. I can go via Rustampur, or I can go via going to Padaleganj. So all the path is different, and all the path will give me different distance. So the path that I am covering during the motion toward the school is the actual distance covered, and it is a scalar quantity. But if we talk about displacement, then the shortest distance between the initial and the final point is of a moving body is called as displacement. Or you can say that if we join two points with a straight line, then that straight line will give us the idea about what is displacement. And you can easily find the displacement by a formula, that is final position minus initial position. Again, this displacement, it has same SI unit, that is meter, and it is a vector quantity. Why vector quantity? Because when we will draw the straight line between the 2 points, we can tell that yes, the straight line is in north direction, or north south, or in east direction, or in west direction. Then we have an idea about what is the direction. So this displacement is a vector quantity. Now if we have to talk about, again same example, my home to surmount the school, then whatsoever path I take, that path may give us different result, or you can say that different distance, but the displacement will always be same. Why displacement will be same? Because when I connect surmount the school with my home through a straight line, that straight line is the actual displacement that has been done by me while moving to school. If we take other example over here, suppose point A to point B, someone is traveling from point A to point B, then he can either go from A to C, C to D, and D to B, or he may take any other path which is available. So that path will give us the distance. But as I join point A to B with a straight line, I got the net displacement. Now there are few things that we have to understand regarding displacement, that this displacement can be positive, negative, or zero. How we understand that it is positive, negative, or zero? So it is very easy. If we subtract the initial position from final position, and if the value is positive, then it is positive displacement. If it is negative, it is negative displacement. And if it becomes zero, or you can see that the initial and the final position is same as in the cyclic loop, then what will happen? The displacement will become zero. Suppose here in the circular, from A we started moving and we reached A ultimately, then it became a cyclic path and the displacement becomes zero. If we talk about the cyclic square, then what will happen? I move from A to B, B to C, C to D, and D to A. The loop is complete and ultimately I reach the same position from where I started. Thus the displacement became zero. And remember that the distance can never be zero, it will always be positive. So on basis of this, try to differentiate between distance and displacement once the lecture is over, because it is very easy to differentiate between displacement and distance. So you can write that distance is the actual path covered, displacement is the shortest distance between 2 points. Then again the distance is a scalar quantity, displacement is vector quantity, and you can also write that distance is always positive, whereas displacement can be positive, negative, and zero. Then there are two types of motion. One is uniform motion and other is non-uniform motion. So if we talk about uniform motion, then a body is said to have uniform motion when it travels equal distance in equal interval of time. Suppose a car is traveling at a constant speed of 60 km per hour. Then in every hour it will cover 60 km only. Then that type of motion is called as uniform circular motion. But if we take from the starting to the braking of the car, that is stopping of the car, then what will happen? Initially the car was at zero speed, and again when it stopped it became at zero speed, and in between the journey it has different speeds. Then that type of motion is called as non-uniform motion. So a body is said to have a non-uniform motion when it travels unequal distance in equal interval of time. Also, in case of non-uniform motion, we cannot determine exactly what is the distance covered at a certain point when seeing this odometer, that is the speed. Why? Because at that speed and in the given set of time the body would have traveled more or less. So the speed that we are seeing, that is instantaneous speed, and to understand what actual distance we covered we have to see the whole set of journey. But if the body is moving uniformly, just by multiplying speed into time you'll get the distance, the same formula that you used in mathematics. Now the rest topics, that is speed, velocity, we'll understand in the next lecture. Till then, try to solve the question that is given in your book and be safe at home. Thank you.